So in this lecture, let's understand about installing an integrated development environment. So in short, we call it as IDE. IDE is a software that contains all the essential tools to develop, compile, link, and debug your code. In some cases, you may have to integrate compiler and debugger tools to the IDE manually. So throughout this course, we will be using Eclipse-based STM32Cube IDE, which is developed by STMicroelectronics to write, compile, debug your embedded system applications on STM32 ARM-based microcontrollers. STM32Cube IDE is an Eclipse-based IDE with STM32 related customization. Let's see how to download STM32Cube IDE. Alright, so just search STM32Cube IDE and go to this link, the official link of st.com, and here actually you have to log in or register to download the software. Or you can do one thing, just click on get software and here select the software according to your machine. So mine is Windows, so I would go for this one. Okay, and the latest version is 1.8.0, and let me just click get latest and accept. And here either you have to log in or register, or you can just mention your email address and ST will send you a link from where you can download the software. Okay, so I'll just enter my email. Okay, and click download, and you can see that it actually has sent one email. So now you have to check your email. You can see that I got one email, start your software download. So just click on download now. Okay, and now just click on get software here. As you can see here, the download has started. So go ahead and download the software and I'll see you in the next lecture. See some of the features of this STM32Cube IDE. In this web page, they have listed some of the key features of this IDE. Let's understand what are the features which are important to us. The very important thing is it supports all the OS platforms. Why? Because it is based on Eclipse. That's why multi-OS support. So that's the good news. And the next important thing is it comes with inbuilt cross compilers and debuggers. You need not to download any external compilers or debuggers to integrate that with this IDE. So everything comes in one single bundle. So this IDE actually uses a GNU-based C++ compiler for ARM embedded processors. It has several other features like importing projects from Atomic, TrueStudio, and System Workbench. And also in this IDE, you find some of the advanced debug features, including SWV, which stands for System Analysis and Real-Time Tracing, which we will be using in this course. And I will be explaining how to use SWV in the later part of the course. And also, of course, you can observe all the CPU core registers, IP registers, and also you can browse various memory locations of the microcontroller while you debug the code. So everything will be covered in this course. And another important feature of this IDE is it has inbuilt support for STM32CubeMX. Now earlier we used to install separate STM32CubeMX software and then we used to generate the code, and after that we used to import that project into the Eclipse software. But with the release of this IDE, that is not required. So it gives inbuilt support for STM32CubeMX for peripheral configuration and code generation. But this feature, that is integrated STM32CubeMX feature, will not be used in this course. So you should remember that we will not be using STM32CubeMX. So now let's install this software. So once you download the archive, so just extract it and here you get the software. So now let's install this. Click on next. I agree, and it will be installing this software into C drive. So that's okay. Let's click next. It installs all these drivers. That's why do not uncheck these things. So these are needed. Let's hit install. It's very simple. So now the installation is complete. Let's click next, and after that click on finish. Alright, so now let's extract this. Okay, so now you have to go under this folder, and this is the installation script which we have to run now. Okay, so for that let's go to the command prompt. I am in that directory and just do ls. Okay, and let's go under this directory. Alright, now let's do ls, and we have to now give executable permission to this script. Okay, for that we have to run sudo chmod +x, okay, and the file name. Alright, press enter. Great. So now let's run by using sudo // and the file name. Right, so now it is getting installed, so please be patient. Alright, so now you have to accept the license agreement. Just press space key and type Y. Right, so and then press enter and the license will be accepted. Alright, so now just be patient. There you go. The installation was successful. Now let's go to the search box and let's search for ST, and here it is. Okay, you can launch this application now. And alright, and here it is. So it is asking for you to open the workspace, and we're not going to open any workspace as of now. Okay, and we can just press cancel here. Great, so now you just installed the STM32Cube IDE on your Ubuntu machine. Okay, and I'll see you in the next lecture. So in this lecture, let's understand installation of GNU compiler collections for host. That means we are going to install the GCC compiler for host. So note that the STM32Cube IDE, which we installed in the previous video, is an integrated development environment software to develop, compile and debug embedded applications for STM32 microcontrollers. So the STM32Cube IDE installation procedure, which we carried out in the previous video, also installed the GCC cross compiler for ARM Cortex-MX processor. So you need not to download any external cross compilers. It is already done. In this course, we are using the same IDE to write and compile C programs for our host machine, that is Windows, Linux and Mac machines. So now we need to install the compiler for our host machine, which doesn't come with the STM32Cube IDE installation. So that we are going to do now. If you are using Linux or Mac, then it is very simple. You just have to run few commands in order to install the GCC compiler for your host. So that I'm going to cover later. But in the next lecture, I'm going to cover how to install GCC for your Windows machine. It is not that straightforward because we use GCC in Windows through a tool called MinGW. MinGW stands for Minimalist GNU Tools for Windows. So it is actually the Windows flavor of GNU tools. So in the next lecture, I will be covering how to install MinGW on your Windows machine. So if you are using Linux or Mac machines, please skip the next video. Alright, so now let's download the MinGW compiler. So I have given a link with this lecture, so you can find in the resource section of this lecture. Please go through that link. So basically it's a Google Drive link. Okay, so there you will find a file called ctools.zip. So you need not to sign in or anything. Okay, you can just download that file. So just download this, and once you download this zip file, okay, actually you have to extract that into the C drive of your computer. So here it is, and in ctools you will find two directories, bin and mingw32. So basically it has all the binaries required to compile and manage the project, C project. So I hope you can do that. And so if you just open the command prompt and if you try to run the GCC command, then it says it is not a recognized command. If you try the remove command, which are essential to clean and build the projects, okay, so but the system says those commands are not recognized, and you may also require to run the make command, and it is also not recognized. So all these commands are actually there, the executables are actually there in these folders. Okay, so now we have to configure these paths into the system environment variables. So for that, so just type env in the Windows search bar and you will get edit the system environment variables. So just open that. Okay, and go to environment variables, and here go to path, edit, new. So first let's give this path. Okay, so just copy this and you can paste here. Okay, and after that get inside mingw32, get inside bin and copy this path and click new and paste here. Now click OK, OK, and OK here. Okay, and now let's close this command prompt and let's run the command prompt once again, and now type GCC and it recognizes the command. Okay, it says GCC is recognized. I mean it may throw this error, but that's not a problem. So the Windows recognized that command. Okay, similarly you can run rm or make. Okay, so now everything is recognized. We have successfully installed the GCC command, which is required to compile our C project. Okay. Alright, so now installing GCC on your Linux machine is very simple. Okay, here I am using Ubuntu machine, so just go to your command prompt and then type sudo apt update. Alright, so please be patient until it finishes this command. Okay, after that just type sudo apt install build essential. Okay, so this is going to install all the essential tools for the build system, including the GCC compiler. Okay, and here you can see that in my case it is showing a build essential is already the newest version because I have already installed it, okay, in my machine. But for you this may not be the case if you are trying for the first time. So for you it would ask you to type Y or N to proceed with the installation. In that case you have to type Y. So then the installation will begin and it will install all the required tools. I hope you can do that, and once the build essential installation is successful, and then you can run the command gcc:\version, okay, to know the version of the newly installed GCC. Okay, and I hope you can do that, and I'll see you in the next lecture. Alright, so now in this lecture let's install host compiler, that is GCC, on Mac machine. To install GCC on Mac machine you first have to install Homebrew. For that open the terminal And now open the web browser and type brew.sh. So here copy this command and paste it onto the terminal and hit enter. So it may ask you to enter the password, okay? Now this installs the homebrew packages on the machine. Please be patient until the installation completes, okay? After that, to install GCC, just type the command brew install GCC and please wait for the completion of the installation. Then you can just type the command GCC to verify the GCC, and here you can see that GCC command is detected and it runs. That's how you install the host compiler GCC on the Mac machine, and I'll see you in the next lecture. Hey, welcome back to the lecture. So in the previous lecture, we actually installed STM32Cube IDE, and in this lecture, let's download all the source codes of this course and let's import all the projects into the STM32Cube IDE. So this is a very important step. I would suggest you to follow this. First, what you do is in your machine, create a folder called Embedded C. You can create it anywhere you prefer. And in that folder, create 3 more folders. The first one is instructor. Here you are going to save the source codes given by the instructor, and then create one more folder called My Workspace, where you are going to develop your applications as you make a progress in this course. And after that, you create one more folder called Downloads, where you are going to keep all the downloaded files or whatever you download, software or whatever you download from the web. You keep that in Downloads. After that, what you have to do is you have to head over to our repository. The repository link is given in the resource section of this lecture. You can just click that. And here click on clone or download and then click on download zip. And you are going to download this into downloads folder. Let's do that. I just downloaded. So now let's extract this. So here you actually have all the source codes of this course. Alright, so after that what you do is you go inside the instructor folder and create 2 more empty folders called host and target. The reason for this is we are going to keep all the projects which we write for our host machine, we are going to keep in this folder. And whatever the projects we are going to write for our embedded target, we are going to keep in this target folder. So create 2 more folders, host and target, and also you should create the same folders under My Workspace also. So here also create host and target. I hope you can do that, and after that what you have to do is you have to launch your STM32Cube IDE. So let's launch it. So here you can see that it is asking you to select a directory as workspace. So what you have to do is you have to go to your embedded C folder, go inside the instructor, go inside the host and select this path and come here and paste here, and now click on launch. So now here you can see that you actually created a Eclipse workspace called host, which is under instructor. So now here you are going to keep all the projects which are written by the instructor for the host. What you have to do now is go to file and click on import. So go to general and here go to existing projects into workspace. Click next. Here you have to give the directory, the root directory. For that, go to embedded C downloads, go to embedded C master, all source codes, host. You just give this path, and after that go back and paste here and then click browse. It will automatically select all the projects, and here click this option, copy projects into workspace, and then click on finish. And after that click on this icon here, restore. So here you can see that all the instructor projects are imported into your local machine. So here you can close this information center. So now you can also close this build analyzer. Just close that static stack. So you can close everything here. Now we will try to compile this. So let me select this first project and try to build this project. And you can see that this project compiles by using a GCC. So, but we have not configured any GCC in this IDE, right? So how it is getting that GCC? Now, the reason for that is in my computer, it has detected some GCC maybe, okay? So if you just right click on that project and if you go to the properties and if you go to the C++ build and if you go to the settings, not settings, go to environment, and here you can see that it has detected MinGW home. So as a result, it is finding the GCC compiler. Now let's try to clean this project. That also works. So for you, it may not be the case. You may see some red cross marks on these projects. So what you do is you have to set your preferences. You have to go to Window and go to Preferences, and here go to C++ and go to Build, okay, and go to Environment. So here you define two variables. That is, the first one is click on Add here. So MinGW home and set its value to ctools MinGW. Right, so that is our MinGW home. Click OK and again add another variable and let's call it as msys home and its value is set to this path, okay, just ctools. Right, and then click on OK, apply and close. So now you go to any project and you just check the project's C++ build and environment section and the values will be reflected here. Now go to one of these project here. Let's take the first project, expand that and right click on that project and try to build that project. So this is called compiling. So just try to build and check the console here. So here you can see that it built successfully. The GCC is invoked and the project has been built successfully and you got the binary. So you should not get any error here. If you want to clean this project, so you can click on clean project here and it should clean up your project. So that means the binary which is generated got deleted. At least these two activities you should be able to do. So now you just imported all the host projects written by the instructor of this course. Now let's import all the embedded target projects written by the instructor. For that, what you have to do is go to File, go to Switch Workspace, click on Other. Here instead of host you just mention the target, or you can go to your embedded C folder and there you go inside the instructor. And if you go under the host, now you can see all the projects in it. You go under the target, so instructor target. So just copy that and go to your Eclipse and paste here. Launch. This is a new workspace called target where we are going to keep all the projects of the embedded target. So this is a new workspace called target. Again, the same procedure. Go to File, Import, General, Existing Projects. Next, go to Downloads, Embedded C Master, All Source Codes, go to Target, and inside here, go to STM32F407 disk. So these are the projects. Copy this path and then go to Eclipse, paste here, click on Browse, and click on Copy Projects into Workspace and then finish. and then click on restore, and then close this. Here you can see that these are the projects which are written for the embedded target. There are more projects to come. So far I have just uploaded these projects into the repository. Let's try compiling. So now let's select one project and then right click on that and click on build and go to console here, and here you can see that the project is cross compiled, isn't it? So now here you can see that the compiler invoked is ARM none ABI GCC. So that's a cross compiler. So now the code is built for the target. So don't worry, all these things you will learn when you create the project. So the build was successful, and now try to clean that. And the clean was also successful. You can see that the binary got deleted. So now you just imported all the projects created by the instructor. So now the instructor folder has all host projects as well as target projects. So do not change any code in the instructor folder. Why? Because it is given by the instructor. So this is for your reference. So if you have any issues while you're working on the project, then you can come back to this folder and you can check the code, or you can launch the workspace and you can build the code. So, but do not try to change the projects. Do not try to edit this. So you create your own project in the My Workspace folder. So here you create the project for host, and here you create the project for the target as instructed in the course. So for that, let's create two more workspace under host and target. For that, what you have to do is you have to go to the Eclipse again, and again switch the workspace. Switch workspace. Let's click on other, and instead of instructor, now you give My Workspace here. That's it. So go to host and copy this path, paste here, launch. This is your workspace for the host. So whenever you want to create a project, you create here. So that will be taught in the course. And after that, let's again create one more workspace for My Workspace target. So this is your target workspace. So whatever the project you want to create for your target, you create here as taught in the course. I'm going to close this Eclipse now for a time being. Let's close this IDE and let's go back to our folder. So this is for your reference, and this is your working area. So in the next lecture, let's see how to create a project. I'll see you in the next lecture. So in this lecture, let me show you how to create a project using STM32Cube IDE. In this course, sometimes we will be creating project for our host. That means the project which is going to run on our host machine. So in my case, host machine is x86 64-bit machine. And sometimes we are going to create project for our target. And the target in our case is STM32 microcontroller based discovery board. Now let's first learn how to create a project for the host. For that, I'm going to launch the STM32Cube IDE, the same IDE we are going to use. And here we are going to open the workspace which we created for our host. So let me type host here, My Workspace host. Let's launch. So go to file and go to new, and then click on C project and click on C manage build here, and then you can click next, and then you can give the project name here. So let me give the name 000, let's say a test project. So this is a project name, and here select MinGW GCC. So if you are creating the project under Windows machine, or you can just select GCC in case you are using Linux or Mac based systems. Since mine is Windows, I'm going to select MinGW GCC. Do not select MCU ARM or Cross GCC. Why? Because we are writing the application for our host. And after that, you can click next and finish. So here you can see that project is created. Let's add a source file. For that, right click and go to new source file. Let me add a source file. Let me call it as main.c. So this is a source file where I'm going to write my C program. Here it is. I just created a main.c file and here we are going to write the code. Let me quickly add some code. So you need not to understand this code. So now I just added a small code snippet into the source file main.c. So you need not to understand this code. Anyway, we are going to learn the C programming from scratch in this course. So I just added some code in order to show you how to build and test the code. Once you write your code into the source file, so what you have to do is you have to build the project. For that, right click on the project and then select build project and then check the console window here. So it will show you all the build logs. For example, let me do it once again. So let me build the project and here you can see that the project is built successfully and the exe is created. That is the executable. So you can also see this exe right over here. You can execute this file. So now let's execute. So for that, what you have to do is you have to go to this path. For that, right click on this exe and select properties and then click on this icon here. So which will open the folder where that exe is present. So here it is. The exe is present here. So just launch that as a Windows command prompt application. So that's how you build and test the code by using this IDE for host. In the next lecture, let's learn how to create a project for the target board. I'll see you in the next lecture. Right, so now in the previous lecture, you actually learned how to create a project for the host. In this lecture, let's create a project for the target. For the target, I'm not going to create here. So for that, we have separate workspace. So let's launch that. So now I'm going to switch the workspace and here let me just type target. Let's launch. Let's create a project. Let's go to File, New, STM32 project. So just wait until it launches the target selector. So it is going to take some time initially. So it is initializing STM32 target selector. So let it happen. So and it does some network activities. So let it happen. Don't cancel it. So now it actually launches the board selector or what you can call it as target selector. Here you have to select your target. So what kind of microcontroller you are using or what kind of board you are using. So that's why there is two types of selection. One is MCU selection and second one is board selection. Since we are using a standard board which is produced by ST Microelectronics, that is STM32F407 Discovery board, we can use board selector here. So but if you have any custom board which is not recognized by ST, then you can just use MCU selector. Suppose if you have any custom board based on STM32 microcontroller, then you can go for MCU selector. In all our lectures, we are going to select through the board selector. So here type your board. In our case the board is 32F4 Discovery. Suppose if you have Nucleo, then you can type Nucleo. So it will list all the Nucleo boards supported. Select according to that. So now let me select STM32F4 Discovery. So here you can see that it shows the picture and all the details about this board. You can browse all the details here and it also, this is a product information. And if you want to get the data sheet, you can just click over here. It will just open the data sheet. So, and if you want to access all the documentation related to this board, click on Docs and Resources. So here you can get the data sheet and the user manual. This is required. So you should download this user manual of the board. So all the documentation you can get right here. After that, what you have to do is you have to click next. So now here you have to give the project name. let me give a project name test project. So here targeted language select as C, and targeted binary type select executable, and targeted project type select empty. This is very important, not STM32Cube. So do not select this unless you know how to work on STM32Cube MX software. So after that, click on finish. So you just created the project for the target. So now you can see the source, and here it has already kept a source file for you. So that is the main.c. So here you can start writing your application, and do not delete any files from this project. So all these files will be explained later in this course. So I'm just showing you the project creation steps. After that, let's close this. After that, go to console and then try to build this project. So let's build this project. So here it is. The cross compiler is invoked and the project is built successfully, and you got the executable which is in the format .elf. So as we make a progress in this course, we'll also learn how to load this project into the target hardware and how to debug the code, how to check the disassembly, how to execute the instructions one by one. So all these things we are going to explore as we make a progress. So with that note, I would like to end this video, and I'll see you in the next lecture. Embedded target that is being used for this course. So in this course, the STM32F407 microcontroller based discovery board is used as the target. Now let's explore some of the important features of this board. So the heart of this board is actually the microcontroller, which is produced by ST Microelectronics. So the exact part number of the microcontroller is this one, STM32F407BGT6. So it's a 32-bit microcontroller, and it is based on the processor ARM Cortex M4 with floating point unit. So this is a microcontroller. And after that, to connect various external components such as LEDs, buttons, LCDs, keypads, and various other things. So a rich set of IO pins are available on the board. So these are actually the IO pins, or what we call as external interfacing headers, IO headers. So there are lots of IO pins are available for your external components interfacing. And this board also has 8 MHz of crystal oscillator in order to supply clock to the microcontroller. Apart from that, another important feature of this board is its onboard programmer and debugger. So this is one of the important features of this board. So if you want to program and debug the code on this hardware, you need not to buy any external programmer and debugger. So the board comes with its own programmer and debugger, what we call as ST-Link V2A. So by using this onboard programmer and debugger, we are going to program and debug our code. So when you install the IDE, that is STM32Cube IDE, the driver for this programmer and debugger will be installed automatically on your machine. Otherwise, ST also gives the separate device drivers for this ST-Link hardware. So you can also download from the ST's website and you can install it. So for detailed information about the board, you have to refer to the user manual and schematic, which is given by the ST. So you can go to this link and you can download those documents. So I have given this link in the resource section of this lecture. So when you go to that link, you will find a section called resource. So just click over that, and then it will display all the related documents such as user manuals and schematics. So just download it. So you need not to explore these documents. So as we make a progress in this course, I will show you how to extract information from this user manual and schematic. So just download it and keep it in your machine. That is sufficient. So how do you connect this board to the PC? Very, very simple. You just need one mini USB cable, which is as shown in this figure. So this cable doesn't come with the board. So remember that you have to procure it, and then you can just use this mini USB connector of the board to connect to the PC. So now this board also has a micro USB connector here. So don't use that. So we don't use this in our course. So that's the only connection you have to do in order to start using this board. So that's about the target, and I'll see you in the next lecture.